Now, in this seventh day, we'll see about how to use analog input and to find the analog value, and also to map using the help of the LCD module, because from the display only we could see the values. So that is why the LCD module is required. Okay. So yesterday we saw about the I2C module with the input. If you press input button one display, input button 2, another display. Okay, I'm using the same circuit. Okay, here then here I'll be using one 10k variable resistor. That is the only addition here. So as usual, you know that this is the nano board. LCD display I'll be using, see, 2-line display. Then I2C module I'll be using. The wire connections already you know it, but anyway, this file is available in the description and as the link. You can download it. In the previous yesterday's thing, we used two push buttons. Oh, so I strike off those things. Okay, it is there, but I strike off. So I will be using the variable resistor. Okay, now using the screwdriver, if I can rotate this one so that the resistance value can be varied between, it is a 10k resistor, so it can be varied between 0 to 10k. So this is the left pin, right pin, the mid pin. The wire connection is already wire connection for the LCD is available here. The wire connection is given here. Left side, left end to 0 volt, this 0 volt, this to 5 volt, this you connected it to A0 pin of Arduino. A0 pin of the Arduino. This is very important. Okay, this is the connection. That's all. Now we go back. So the Arduino has how many analogs? Analog 0, analog 1, 2, 3, 4, 5, 6, 7, 8. Arduino Nano board has 8 analog pins, whereas Arduino Uno has only 6 analog pins only. Okay, so it has 2 more analog pins actually. You know that this particular I2C module already it has taken A4 and A5 already. So this A4, analog 4 and analog 5 A5 are required to connect the LCD module through I2C or I2C. So you have 8 minus 2, 6 more analog channels are available. Now in this exercise I used analog 0, A0 pin, this pin. Okay, in addition to that, already I connected D2 and D3 for the push buttons. You ignore it. I'm not using it here. It will be there, but in the loop, in the program, I didn't set any action for these things. If you want, you can take it. Then make a note of it. The analog inputs, you know, before seeing the program, the analog, let me make it bigger, maybe in different color. The analog input is with 10-bit resolution. Meaning, (10-bit) means 2 power 10. 2 power 10 equal to 0 to 1024 divisions. So here that means 0 is the first digit as far as the Arduino is concerned. So 0 to 1023 divisions, 0 to 1023, totally 1024 divisions you can get it, because it is a 10-bit system, this particular board. Some boards are having with 12-bit, 14-bit, 16-bit, 30-bit and so on. The weighing machines and all, it is having maybe a 24-bit system. So the number of divisions you can, that is why you can see the even the milligrams, because the resolution is high. So from this you will understand about, say for example, the goldsmith will be using very accurate weighing machines, so the bit is higher to instead of 10 bit, they may go for 24 bit or so. So 1 milligram accuracy they can get it. So that is possible only if you increase the bit. Okay, so this 24 bit is well and good. So from this aspect I could say this kind of facility or feature or flexibility is not there in PLC actually. uh, when it comes to analog, boards are much costlier as far as PLC analog boards are much costlier. But for this 300 rupees, you have 8 analog channels and 16 digital channels in Arduino, so it is really damn cheap actually. What is just filling? Analog is okay, analog. Okay, so this is the program. Let me show you the program. Okay, now these things you can ignore, but anyway let it be as such. Okay, see, this is the thing, sensor pin. I am using sensor pin that is connected with A0. So let me go to this one. The image is not that good, so I connected this one, this is the variable resistor. So the midpoint, you see this wire is connected with this A0. So this is A0, this is A0, they connected here, midpoint. This left end connected to 0 volt, this right end connected to 5 volt. Very simple. The IDC connection. So this particular knob is at the left extreme. So that is why the value, actual value is 0, the mapped value is 1. I'll tell you now actual value and mapped value. Sensor pin is assigned with 0. The sensor value initially at 0. Map value variable also I am using. This is the setup block. We see the loop block. So the program is only 2-line program. Sensor value, it reads the analog value from the sensor pin. It is that value stored in analog sensor value. Then I am using map command. This is the syntax for the map. That is already I said it is a 10-bit system, so first value is 0, last value is not the 1024, it is 1023 because first digit is 0. So this 0 to 1024, that is 0 to 1023 is mapped with 1 to 101. Okay, so thereby actual value you will be seeing, the mapped value also you will be seeing in the second line. Okay, instead of using 101, if we say 10 or 11 maybe. Okay, so 0 will be 1, 1023 will be 10 or 11. That's it. So here I get this 1000 divisions mapped to 100 divisions. Instead of 100 or 101, if I use a 10, this 1024 division is mapped to 10 divisions. That is a logic. So these are the standard thing. Don't strain much yourself. You just copy it and paste it in your Arduino IDE, Arduino compiler. Right now I am using Arduino 1.8.10. Right. So just verify first of all whether the program is good. It will be okay. Suppose if the library files are not installed in your system properly, you will get some error message. Then as I said earlier, install those library files using this include library command. Then the port is also, while fusing the program uploading the program onto the board, these things are important. Either you can use Uno also you can use. So you have to choose set instead of Nano, you have to set Uno. Now all along I will be using Nano. So I have 3 different types and port. These 3 things are important. Then only you are able to upload the program onto the Arduino board. Okay, that's it. Shall we see the program now? The running, I compiled. I fused the program already. Now let me play the video. Now the program is there. It is, so now you see, using the screwdriver I am about to turn either clockwise or anti-clockwise. So initially it is 0. So slowly I will be tilting and rotating it in clockwise direction, you see actual value and mapped value. Proportionate, the maximum is here the 1023, so that is corresponding to 100 or 101 maybe. Yeah, 101. 1023 corresponds to 101. Instead of 101 in the program, let me pass. Go back to the program. Here instead of 101, if you put 10, this 1023 corresponding to 10. Now I will be showing the tilting also. Let me show now. You see the screen now tilted to 0. The zoom out. You see I'm slowly. Yeah, I tilted to certain distance. Now the value is somewhat increasing. Tilt is some more. Increased. Some more. Value still increased. I think tilting to the its extreme. That's it. Okay, so this is the program for finding the analog value, because these things you need in developing some real products. Okay, so this file contains everything. This file is the program is here. These things you can remove if you want. If you remove those things, you have to remove this also. Okay, so you copy entire content, you can run it. Even though if you have the software, you just copy, you can verify the program. You can just verify the program by using this tick mark. You can verify the program. If you have the board, then only you can upload the program onto the board and you can physically see that. Otherwise this is enough. Okay, serial communication. Yeah, serial communication is not connected. Okay, the board is not connected. One more thing I would like to tell you. Yeah, I didn't give any command. Okay, so today you saw about how to find the analog, how to use the analog input to find its value, and also using the mapping command also. Okay, through LCD we saw all those values. Okay, so that's it. That is the end of it. Now if you like my channel, you please subscribe it, inform this to others, your friends and students, so then they will also get benefit from my sessions actually. Thank you.